Last time, we talked about the figure or my geometric model, BoomSun prism. And just a quick review, it looks like this, wherein the front is labeled as A to H and the back is labeled as 1 to 8. And last time, we have proven that the geometric model is indeed form a group structure. Now, let's check if the geometric model forms some subgroups. But first, let's define what is a subgroup. A subgroup is defined as a subset of a group that itself forms a group under the same operation as the original group. Meaning, from the word subgroup, meaning we're gonna form a group from the group or from the group structure we have. So subgroups have three types. The first one is the improper subgroup. So improper subgroup consists the set itself or the original set, which is A, B, C, D, E, F, G, H, 1, 2, 3, 4, 5, 6, 7, and 8. So when we talked about improper subgroup, it just talks about the original set that we have. So for the next one, we have the proper subgroup. So in this part, this is where we're gonna verify if there are subgroups formed in our group. So I have here 1, 2, 3, 4, 5, 6, 7, 8, and 9 proper subgroups. And later on, we will talk about them one by one. And then for the last one is the trivial subgroup, wherein this consists the identity element of our structure. So for the first one, we have is the improper subgroup. So since it's just the set itself, we're just gonna put it like this, and we don't need to prove it again or to verify if it forms a group structure because it is the original um, group or the structure that we have. And for the next one is the proper subgroups. So for the first proper subgroup is Z sub 1, wherein it has the elements A, B, C, D, E, F, G, and then H. And as we can see here in our table, all the elements um, formed or all the resulting elements from the set is or from the table is in our original set. Okay, let's use a laser point. So as you can see here, A up to letter H. There are no other letters and there are no numbers since our original set as only or just consists A to H, meaning our subgroup is closed because all the resulting elements are found in the set. Next, let's check if it forms associativity. So again, by inserting and interchanging rows and columns, the resulting elements in the flipped table can be arranged like on the original table of results of the geometric model. So let's check. As we can see here, this is the one of flipped or rotate at 180 degrees. And by interchanging our elements, row and columns, we went back to the original structure, which is this. So meaning it is or it forms associativity. Next, let's identify the identity. And as always, the identity element is A, which is also in our set. And our inverses are the following. So the inverse of A is A, the inverse of B is H, the inverse of C is G, the inverse of D is F, the inverse of E is E, the inverse of F is D, the inverse of G is C, and the inverse of H is B, wherein all these elements are also in our original set. So meaning our first proper subgroup it formed a group, meaning it is a subgroup of our structure. Now, let's have this or the following or the other subgroups that we have obtained. So we have here is the Z sub 2, which is A and 1. So as you can see here, this is the original table and all the resulting elements are found in the set. So we have here is the associativity. Associativity meaning rotated it when we rotated it in 180 degrees, um, The resulting table is the same as our original table. And inverses, so I haven't included in here, but our inverse is the inverse of A is A and the inverse of 1 is 1. Now, let's have, so just like this, Z sub 3 is A and 2. So just like in here, it is also closed and it forms associativity and has the inverses, or rather first has the identity A, and the inverses A is of inverses as A inverses A and 2 inverse is 2. So for the next one is we have Z sub 4 that has the elements A and 3. So just like the previous two or the first two, it it is also closed because all the resulting elements are found in the set, and it forms associativity because when we rotated it 180 degrees, it formed the same table as our original table, and it has the identity element A and the inverses wherein A inverse is A and 3 inverse is 3. So same process to our preceding subgroups because they just have, since they will have the same process because they all have the identity element A, and um each each subgroups has one number from our original set, because remember from our original set, the inverse of our numbers is themselves. So meaning when we rotate it and when we get their inverses, it is also included um in our set. So we also have Z sub 6. It is closed, it forms associativity and has identity and inverse, wherein um Z sub 7 elements A and 6 also is closure, forms associativity, has an identity and inverse, also A and Z sub 8 and Z sub 9. Now, let's move on to our trivial subgroup. So remember from what I've said earlier, the trivial subgroup consists the identity element. So if we have the identity element only or one element only, so whatever rotation we will do or whatever we do, it is closed, it forms associativity, and of course has the identity and has the inverse, which is also letter A. So from all the subgroups that I have formed from our geometric model, we have this lattice diagram. So we have here the improper subgroup, and now we have here the proper subgroups who are distributed or differentiated by the numbers. And then we have here the identity element, which is the trivial subgroup. So now that is the end of the subgroups of the geometric model BoomSun prism.